And just a note of thanks to Sandvik, which is a diamond sponsor of the Progressive Mine Forum, and to Hardline, which is a gold sponsor. So we have a big job today to discuss both automation and big data in one panel. Last year, it was two separate panels. So we'll do our best. What we're really talking about today is the digital and automated mine of the future, the blueprint for how to get there, and how miners can reap the rewards of existing and emerging technology right now. And we've already heard that there is a lot of technology that's available that miners can take advantage of. So let's start with the automation side. Automation is not new to the industry. Eddie, can you give us some idea of the existing level of automation in underground mining and some of the drivers towards automation?
Sure. So I guess the technology itself is not necessarily new. I mean, there's been various levels of operating equipment, either remotely or with automation, for going on the best part of 15 years now. Within Sandvik, we've been doing it at Codelco since 2004. And in the early days, a lot of the drivers were around safety and eliminating people or removing people from the dangerous workplaces. But it's really just been in the kind of the last 2 years where the whole push around productivity and utilization really drove the opportunity to increase your production at mine sites there, and that's where we've really seen a lot of growth with a lot of the collaboration of our partners over the last 2 years. We kind of speak about the automated mine of the future and how it's going to look. I touched earlier before about a mine in Mali, of all places in the world, that we've been partnering with for the best part of 2 to 3 years. And they've kind of promoted themselves as being the first digital mine in the world, and that includes operating all their equipment from surface via automation, be it their trucks, their loaders, their production drills, all their mining equipment. And that's been a 2-year journey. And I mean, how that came about and kind of the theme around today was it came around from a vision from their senior management and their CEO saying that we need to do things differently in a country like Mali. So conventionally in West Africa, these mining companies, they'll bring in an Australian contractor who might cost the best part of $250,000 to be as an operator. And that really wasn't a sustainable part of the business for them going forward, and how they saw their business being a partner in that community. So they saw automation and technology as a step change in how they leverage or create a sustainable partnership with the local community. And to the point there, one of their managers, I had a conversation with him, and he was kind of saying, maybe 20 to 30% of the population or the local community might have had a high school education, but 80-90% of them all knew how to operate a cell phone, kind of thing. And that was one of the light bulb moments for them to say, look, technology in this community, it's not such a big step change, but maybe some of these other skill sets were. But like I said, that's just part of how they see the future of being a sustainable digital miner in their community.
So there are a lot of options when it comes to automation and getting workers away from the dangers underground. And a lot of it is proven technology. As Eddie mentioned, this has been around for 15 years or more. And we saw a lot of compelling metrics in Eddie's presentation earlier today. Walter, can you talk a little bit about why the adoption rates of automation aren't higher?
In any type of business, it costs money to step forward, to move forward. And in mining, there's a lot of discussion about the old timers around for a long time, and they know how to break rock, and they've been breaking it for a long time. And it takes a truck, and it takes an LHD, and it takes a drill, and it takes all this equipment. So all these existing mines, these producing mines that are out there, they have all this equipment already. So our company, we specialize in the used equipment, retrofitting machinery. And what happens is you get into a project where they see the need. Everybody understands that you either start adopting these new technologies and new ways of mining, or you're going to die. Eventually this is not a choice of doing it or not doing it. You have to do it. So you get involved in a project, and the mine has the mine manager and all the people in the mine, they have a mandate. They need to move so much ore every day. If they don't move that, shareholders pull their money out and, well, they give it to Apple. We don't give it to somebody who makes more money. It's that simple. So what happens is you, in these projects where you're retrofitting machines and you're trying to introduce new technologies, and it comes down to we move ore or we give you a machine to work with, they don't give us the machine. So you end up on site for a long time, projects drag, and it takes a lot of willpower to just force these projects through. Now, that sounded really negative. We have done over 3,000 projects in the 24 years or so since we've been in business, so we do it successfully, but you have to have the people on site. So the real answer to everything is the players, and it's all people at the end of the day. If those people are not on board 100% with taking this major change, and it's kind of not a step change, it's a major change from sending everybody underground to sending technicians underground to fix a machine and running it from surface. You have to have everybody online to actually make those projects go through. I agree. It's only the last couple of years where we've actually seen the adoption rate actually start to change now.
We're going to talk a little bit more about that people aspect a little bit later on. But for now, I want to talk a little bit about the limitations of automated technology underground. Currently, automated machinery has to be kept separate from manually operated machinery for safety reasons. Eddie, can you tell us how far away we are from being able to operate mixed fleets underground and whether that's a necessary step towards the mine of the future?
Sure. So, I mean, when you say mixed fleet, we speak about having people operating in the same active zone as an autonomous piece of equipment. So, until now, I mean, the safety ratings is probably, it's been a limitation, but it's also been a barrier to being able to do that on purpose, because the detection and the technology around scanning and people detection has created a barrier to eliminate those kind of safety potential risks. Be it, and so it's social as much as the technology side of things as well. I mean, the perception is that there's somebody operating equipment, potentially, take Musselwhite, for example, there, where you're operating equipment from Thunder Bay. I mean, I know I'd be pretty scared if I was in that same stope as somebody from Thunder Bay operating 1,000 kilometers away. So, I mean, the technology is coming and is definitely in development as we speak. But it's definitely, we're talking in the years kind of thing before you get into that collision avoidance detection and that having that level of safety that matches people's assurity that they'll be operating and coming home safe every day. But in saying that, though, I mean, the other opportunity with if that becomes a parameter or a barrier to entry, then you can start looking at changing your mine plan. So all of a sudden you have 2 shifts a day, you have a manual shift in the day, and then you have an automated shift during the evenings. And those are the kind of concepts that, with those limitations may create opportunities as well. So there's several ways to look at it and not just this, okay, it is a limitation, but does that drive innovation around a conventional mindset of or you have to have manual people down there 24/7? Is that a necessary evil? Mm-hmm. So.
Communications networks play a big part in enabling both automation and big data applications in underground mines. Does anyone have a perspective on how LTE and 5G technology is going to change mining, or is it already changing mining? Walter?
I'm just thinking, should I go nasty on this one or not? In the early, don't do it. That's good advice, yes. Back in the early 2000s, arguably we may have been, this is before Wi-Fi was even a word, it didn't even exist. We were testing that technology underground at Falconbridge Mines with telephones. They didn't call it Wi-Fi. It was a proprietary standard at the time. We were testing this. We proved it. It worked. Ventilation on demand, vehicle tracking. This is early 2000s. And the people who sold the communication systems at the time, this is the last time anybody actually moved any data over a leaky feeder system. Okay? Which mine doesn't have Wi-Fi underground now? In that day, everybody said it wouldn't work. So what happens is in any industry, Wi-Fi is a standard now. So how's the new guy come and sell something else? Well, I start talking 4G and 5G and 5L, and in 10 years it'll be something else. There's always a new technology. So speaking from experience, and I'm sure you could agree with this one, as suppliers in this industry, they all work. We just have to work with them, that's all. So, you know, it's there, it's going to work. Is it the best for every situation? No. But people don't understand that when it comes to cellular networks, and I'm going technical on this one here, but cellular and Wi-Fi, the cell networks back putting Wi-Fi into restaurants and Tim Hortons and McDonald's to get the bandwidth back for their cellular networks. So it's not one or the other, it's both. It depends on the circumstances. Not one's better or one's worse, it's both.
I want to introduce the big data side of the conversation a little bit more formally. Maybe Pavel can talk to some of the, what are some of the applications and capabilities of big data in mining right now? How is it being used?
Sure. Is it working? Can you hear me at the back? Yeah, good. Well, thank you for having me back. You know, I did want to start with an analogy, just for perhaps in this room, because in the industry, it seems we kind of frame the problem wrong when we talk about big data. Big data to analytics or AI is no different than fuel to a machine. We don't talk about what we're going to do with all this fuel, right? We talk about the way we have to move certain things, we have to be more efficient. We talk about outcome. And I think with big data, that's the shift. I think I was here 2 years ago, probably, that at least from our experiences, we're seeing definitely globally, but certainly with all the mining companies in Canada, the shift towards a value schedule. And, you know, there's been all kind of public announcement of value schedule. Tech Resources made public announcement of amount of value to be created in 2019 with their digital investments. Suncor has announced their value scheduled. There are a couple of other clients that we're active with that we would like them to start to talk about value schedule. Because value schedule really comes down to use cases at priority areas where there's executive sponsorship, to your point, already there, and the end users are ready to adopt these technologies. From an example perspective, there's been a lot of popular topics in this conference around exploration with IBM's work. That is continuing at multiple sites with other companies. Use cases all around how to be more intelligent with the drilling budgets related work. A lot more use cases are coming into the operation aspect of it. Things like haul cycle analytics, things like predictive maintenance, those kind of inventory optimization, those kind of use cases. Also in processing, so process plants. If plants are instrumented with PyHistorian or some sort of a sensor-based information, how can you do a real-time prediction of a big loss of value event, which could be multi-million dollars, and then how do you run different types of optimization scenario in real time so the plant operator can do something about it in the next 10 to 15 minutes to save millions of dollars of value. And then also in the shipping side of things, around network optimization, around logistics optimizations, all the way to retail aspect of it. So from both pit to port, we see lots of use cases. Some companies are talking about, some mining companies are talking about becoming software companies. So there's been lots of momentum we see in the last 2 years.
Does anyone else want to talk about use cases? Louis-Pierre?
Sure. I mean, I think in underground in particular, we're seeing a lot of these event detection, so production event detections that are based on that. And I think globally, at least in the underground part, we're seeing more of the here and now kind of applications of data science being, it's not necessarily predictive or predictions about what's going to happen. It's more where are we and the ability to really collect data and know, like what was the actual production? When did my truck start this morning? Why did it start I don't know, 2 hours later than the beginning of the shift? And so I think the global trend right now is like, where are we? And then probably in the future, we're going to see more of the, like, where are we going with that? Mm-hmm. So predictive analytics and all of that stuff.
Mm-hmm. So miners already have a lot of data right now. I'm just wondering how they can make better use of it. Steve, you had a lot of success with Integra Gold by making your data available and getting outside parties to assist in your exploration targeting through the Integra Gold Challenge. I'm just wondering what advice you would have for other companies in making use of their data.
So, so in 2014, we made an acquisition. We bought a processing facility out of bankruptcy, and it came with this big data set. And we didn't know what to do with it, so we took a page out of Rob McEwen's book. For 15 years earlier, had done the Gold Corp Challenge. And we had a big exploration program. We didn't have any time to spend on that, kind of digging through this old data set. A lot of it was digital, but digital being scanned copies of underground handwritten drawings, so not quite digital. But we took the 6 terabyte database and we just put it online. And we spent about $1 million cleaning it out. So I think big data doesn't really answer your question, but I think one thing that's very important with just data in general is the quality of that data. Our data set came from 2 different mines, and those 2 mines, even though they're only 500 meters apart, they never spoke to each other. So it may as well have been written in sort of Chinese and Russian, even though that kind of the kind of granodiorite was granodiorite in this scenario. You may have had 8 different ways to describe it, and you could have 3. So we had to standardize that data set. And then we put it online, and the idea was, well, anyone with any idea out there can take a look at this data and tell us where we should look for more gold, and it was a gold primary. And to Nathan's earlier point, which I couldn't agree with more, you've got this sort of mentality towards innovation around kind of everyone would ask for a faster horse, not a car. And I don't think we really apply that method, and I can't say that we sort of tried to, but looking back, I think we would have even done that challenge very differently in a lot of different ways, because we very much said, like, tell us where within this sort of little plot of land we should look to drill gold, look to drill for gold. Where did they miss? What I kind of learned through that process, and sort of fortunately, unfortunately, our company shortly thereafter went through a sales process. So we had these phenomenal targets from 1,500 people from 90 countries, and teams of all kinds of different kind of scientific backgrounds had given us. We didn't really get a chance to test them all. So I can't speak to the kind of did it work or not, because the company that bought our company was entirely hyper-focused on just bringing the mine into production, not so much the exploration potential. And they're starting to unveil that now. But kind of when I look back at that experience, I think what I really learned from it is what we need to do with innovation in general, and this is data science, but this is kind of big data, this is innovation in general, is we need to find ways to measure success, and then we need to find ways to promote success that kind of inspire other people to continue to do the same thing. And when I look at that challenge that we did, even though we didn't ultimately make a massive gold discovery from it, we hosted a gala with 600 people that raised $250,000 for charity, that we eventually gave all that money back to the local community, and it was all based off this kind of ancient data set that had no use to us. And it was through that whole experience that we realized there's so much more to innovation than really just kind of putting things online and hoping for answers, or applying machine learning or disruption or every other buzzword out there to it. I think if we can clearly define kind of what our objective is with big data or innovation in general, we will have much more success as a sector in kind of achieving that. And I think there are so many examples of kind of innovation that, innovation that kind of we're working on today, but I don't think we've really clearly outlined the benefits to those. If it's to make trucks a little bit faster, I think we need to take a step back and think a little bit bigger than that. So, sorry, it's a little more than just data science in general. To your data science, to that part specifically, I really think we just need to identify the problems that we're trying to achieve. And then kind of when they're achieved, I don't think the work's done at that point. I think we all make the mistake of thinking that in itself is good enough. It's really going to be taking those achievements and then kind of putting them in a way that kind of be it universities or other companies or everyone else can use. Because when we look at other sectors and what they do, a lot of it comes to kind of first kind of seeing the opportunity from data science and everything else, but then also sharing that information with, it might be competitors, with other groups, and then building on it and building on it and building on it. And hopefully with all that, we can start to close that 30-year gap. That 30-year gap. I think it's probably 40 or 50 years, But that's where the opportunity is.
I'll just quickly add there, Steve. One thing that we're seeing as we are engaged with lots of these companies, at least on the exploration side, obviously we all want to find answer. But what's critical is what are the right questions to ask with the data? So that ability to explore data, I know the business audience would always drive towards what did you find? But that ability to explore data, ask a different question, is so key, and especially to the previous point of attracting the geologists who are 22, 23-year-olds. They simply don't want to do the manual work that is necessary to put multiple data sets together. From a talent attraction and higher quality work perspective, we have to focus on, are we asking the right question? Are we enabling people with the right decision support so they can actually explore data better? In addition to what answer did you find?
Nadine, you have a really interesting perspective coming from the mining side, a lot of experience on the mining side as a geotechnical engineer, and now working for a venture capital firm that invests in cybersecurity and intelligence technology. So two very different industries moving at two very different speeds.
Very different.
So how has your perspective on the mining industry changed from this new experience you have?
Well, it's so interesting to see, to go from, might not be a popular opinion, but we talk a lot about innovation in mining, but we have a real problem adopting new technologies before, so we need to learn how to crawl before we walk. So I think we should focus on adopting, and I'm now in an industry where it is hyper, so it's early adopters. We're talking terror attacks and corporate cyber attacks. And we're investing in companies that we don't discuss big data, it's just machine learning now. And so it's the machine that is, the algorithm that is learning. We invested in one company. It's no longer facial recognition for crowds, it's motion recognition, because the attacker probably isn't known to Interpol, and it's their movement that we're looking at. And so you're looking at tens of thousands of people at the same time, or processing going through an airport. So and when you go to a company or you go to someone with that technology, they don't ask who's installed it before. Where in mining, if you have a new business, the first thing they say is, well, where else have you put it in? And they don't want to be the first one. Nobody does, because what's my ROI? I don't know. You would be the first. Even if you're looking at other industries. For example, the chemical industry, which also has processing plants. They'll adopt a new technology way before mining. I think my father, back in the early 90s, late 80s, he was working at CIL, a chemical company, and they were the first implementers of SAP. I would guarantee you that there are mining companies out there that still don't have SAP or Oracle. So we're very slow. So we're on geologic time, and cybersecurity is on, they've got the time machine, right? They can go backwards and forwards. So I say shame on us. I say we should really look at people that are coming out with innovative ideas that can help. I mean, if you look at Adobe spun off an organization called Kickbox. So it's kickbox.org, and it was Mark Randall, who used to be the chief innovation officer at Adobe. And this is a box that you get, or you would get at Adobe. As an employee, you would request it, and it gave you a $1,000 credit card. And with that credit card, you had your own project, and you could show, if you could show some way to make a new product or a new innovation within Adobe, nobody asked any questions how you use that $1,000. And what Mark said when I met him 18 months ago in Palo Alto is he said from that red box, they have 17 products that were now coming out of Adobe. And that kickbox.org, if you look at it, it's been highlighted in the Times all over the place. Why don't we do that in our companies? Why don't we say to all of our engineers, maybe you've got a good idea to help improve underground systems. You know, we don't celebrate ideas, we kind of push them down. So I say we need to learn, we need to change our culture.
And even before you get to inventing or innovating new ideas, there are off-the-shelf technologies that are available from other industries. Can you tell us a few ideas?
Yeah. So one of it's a company called Siga OT. It's based in Israel, and it's a cybersecurity company, but it goes into process plants, like the New York Power Authority is putting it in. And because they're using an algorithm that is machine learning, it's actually coming back and telling their clients how to improve their plants. So when I heard about this investment, I said to my boss, I said, this would be great for mining. I go, because what it does, they call it prescriptive maintenance. So this algorithm will tell you before you know what's going on in your process plant that you need to fix something. What you thought was optimal may not be your plant running at its optimum, and it will tell you. It'll have new correlations that you might not have even known about. I went to Israel to a chemical plant in Beersheba, and I got to see firsthand the system in use. And I didn't understand what they were saying in Hebrew, but I certainly understood the engineers and their mannerisms because they had just had a failure. And this technology was telling them that what they thought had caused the failure hadn't. And so that saves you time too. So, yeah.
So I'll just say, I think you're talking about set point optimization at plants.
Yeah, so this technology, it's not at the PLC level, which is level 0 on the Purdue scale. It's at level 0. It monitors the electrical signals.
Okay.
So it's at level 0. They are the only company that we're aware of in the world that monitors the electrical signals in your plant. They have 4 US patents, which is their barrier to entry. And so the New York Power Authority, they're in a nuclear facility, they're in a few other facilities. So they have 25 installations. And then when you talk to somebody in mining, they're like, any mining? No.
Yeah, I mean, but in terms of, and it makes sense, in terms of process optimization, we're seeing that across all of our clients, significant value, simply because most of these organizations have PLCs in place, which is basically, predefined parameters of a system. But that system is optimized only based on that system. Now the discussion is system of systems optimization. One of our clients, Suncor, their base plant is as big as half of northern San Francisco. They have many, many plants. So you have all these mini plant managers who have been given sort of these parameters, how they were operating. But now that you have real-time feed from those processes, as well as scenario generation capability in real time, just like how a schedule gets put together for an airport or any other sophisticated optimization techniques, there's a group called site-wide leads. They are the super users or super plant managers, and they're overriding based on overall system performance, not just the individual siloed optimization. Because I think what we have done in the heavy industry, we have done very good vertical optimization in a small unit. Now it's a time to go actually horizontal at a higher level, so you're making better overall decision, not just a unit level optimization decisions.
Going back to the underground mine and for some of the suppliers on the panel, your machines are covered with sensors. Are your clients making good use of this data, and how can they make better use of it? Louis-Pierre, why don't you start?
Well, I think it all depends on the clients, obviously, but one way to make better use of this data, and this I think is a recurrent theme here, is to standardize the data. Because right now, there's a lot of data set coming in from different part of the mine that are optimized locally, as Pavel said, and we're not taking into consideration the big pictures. And like, there's a reason why it's called big data and not siloed, independent, and data that doesn't talk to each other. is because this is where the real power is. Like just with predictive maintenance, we've seen great improvement in predicting power based on do you train on one vehicle, do you train on 10 vehicles, or 10 vehicles from 10 different mines? And so I think that's standardization in order to be able to sort of put the data together is really the way to go to make more out of this data.
So how easy is that to do? Do they need a data scientist on staff? How do they do that?
Well, obviously you need someone who understands the data. So it needs to be someone in the mining. It needs to come from the mines because I don't think someone who's never been underground can really figure out from lines of zeros and ones. Well, this is exactly the same thing as this, so we're just going to put it into the same column. And so it needs, well, both involvement from the miners or the maintenance guys and also from someone who has the capability technology-wise to really do what, say, the miners are actually describing or what the maintenance manager would like to do with the data. Because in the end, like an engine oil pressure from a Sandvik or a Caterpillar is an engine oil pressure. They might not be called the same way, but there's a ground truth in there that needs to be exploited.
Eddie or Walter, do you want to weigh in?
There's we're in a little different situation. Is we do a lot of remote control and tele-remote control on machinery. So although we have access to some of the sensors, we don't collect that much data. The part that was always missing, and it's just recently in the last couple of years is getting any traction, is when you try to automate something, typically a human can do the job very well. We're not very good at doing it repetitively. So one of the problems we ran into is we're in an industry that is governed and watched so closely that it was very hard to try and get any of our customers, we have a lot of them, that would actually allow us to record video. Because we have the data of what the machine's doing, but we don't have the video of what it's actually, why the guy did it. So for instance, but we have about 70 installations of tele-remote controlled rock breakers in mines, mostly in underground mines. I can see that the boom moved to the left, but why did the guy go there to the left? Was the rock bigger? Was there a crack in it? What did he see? Because we don't have the video. And it's actually just this month actually, where we've actually got permission from several of our customers to start recording the video and the data simultaneously. Now, the reason for that is really simple. Historically, if you sat and you went underground, you watched a guy run a machine, he's on his best behavior. But do that at 3 o'clock in the morning, and he's doing stuff he's not supposed to do because he can get the job done. So maybe if his hammer's not working right, he'll take it and try and jam it through the grizzly and break the machinery. So they use it for punishment purposes. And that's kind of the agreement, is don't punish people for doing it. Let them do what they do. Watch why they do it. And then let's see if we can figure out how to do it better. And we can, this just from historical data. But it's kind of a different thing. It's not the machine. What we need to do is match the machine with what the person's actually doing and why he's doing it.
Yeah, it's a really good point. And I mean, what I see with data and how Sandvik is starting to see data is, as an industry, we take anecdotes and we take, the last person's mine design and we take, 10 years ago. So what we get is a mine plan from the 1990s that's got 10% factor from the engineering group, and then the mining engineer doesn't believe it, so they put another 10% factor on it. So it's all based on somebody's anecdotes from several generations in some cases. And what big data and data in real time and all this information allows you to do is make decisions and design mines in real time to technology that exists today. And I think that's really going to be a key enabler going forward in the next generation of mines, is stop looking at an ore body from a 1990s perspective. Let's look at it from a 2020s perspective. And how can we make this the most optimized ore body? I mean, are we using a cutoff grade that's only 5 grams per ton because we're using a $60 per ton cutoff grade or a mining cost? Well, hang on, we know with our operating costs in 2020, these are much lower. Well, we can do this and apply these technologies. And that's those data sets that also support those business decisions that can go all the way back up to the top of the business decision and then that can filter back through the business as KPIs and business drivers going forward to monitor and control those costs. So it creates a lot of opportunities, but I mean, you go to some mines and I mean, they want the data, but then they don't have the underground network installed, so they've got to drive past one access point in the mine to gain the data that they may only get once a month or once a week. Or they may not even have an IT person on site or a data scientist on site that can actually compute or able to understand the data or understand the network to install it. So, I mean, if we look at it, these technologies from a historical lens, I mean, there's a lot of limitations in how people approach it. It becomes self-fulfilling that the system or the technology doesn't get the value realization that it could.
So let me add something there. 2 data points for you. If you look at the most, as we look through all the industries, the social media and the big techs are probably the furthest ahead from a data internal resources point of view. They have thousands of people, like working on machine learning models. An example would be, the ad that shows up on your Google screen. It's not a coincidence why that's there, right? Thousands of people are working on to make sure the right ad showing up to the right eyeballs. If you look at the middle of the pack, most banks in this city have 400 to 600 people working on data analytics type of use cases. And unfortunately, probably mining, and I like that chart somebody was showing before, mining and agribusiness. If you look at the left side of the spectrum, some of the big boys, they're starting to have, in total, 100, 150 people as a total project team, internal, external resources. Some of those companies will start to have 20, 30, 40 people internally that's focused on data analytics. Second data point I want to kind of share with you, I think we have to think about data scientists, data engineers in a different way. The future geologist, the future exploration analyst, the future mechanics, they're all going to be data scientists. They're just going to be geologists first. Then they're going to know how to run Python codes and all sorts of things. So the world is moving in a space where everybody is going to be a data savvy professional. Their first degree might be in geology or exploration, but they're certainly picking up with all the open source technology and education that's available. In our consulting practice, we have 250 people. Bulk of those people started with different types of domains that has nothing to do with data analytics, but they came from geophysics or physics, astrophysics, neuroscience, biology, and then picked up tools, and now they're applying that in a particular industry. So that's how I would think about how the evolution we see in these large and also mid-sized companies.
We just have a minute left, so I just want to pick up on a point that Nadine made. I'm sure you've all seen examples of successful adoption of new technology and not so successful. What makes the difference? What makes a company successful when they adopt new technology? Louis-Pierre, do you want to start?
Well, I think there's a big part of it that is planning change management, especially with things that mark the imagination as like artificial intelligence. Everybody's heard of it. Everybody's sort of afraid of it, afraid of admitting it, maybe. But I think we have to be cautious in how fast or how pushy we are with those technologies. We have to really plan long term on how these technologies are going to be received, or else, well, we might see something like in the presentation from this morning, having a backlash of getting people angry at the technology and really not helping us making this step forward, this new thing.
Steve and Nadine, and then we'll leave it there.
Yeah, I think success is ultimately defined by kind of what are we trying to achieve? Like to the example of, are we trying to make trucks more efficient? Or are we trying to make mining cheaper? Or what is the ultimate objective? I think the ultimate objective is to kind of get ore out of the ground for the lowest amount of money as possible, and ideally with the least amount of impact on the environment at the same time. So I think in the future we should be defining success based on pretty simple metrics, like kind of what kind of makes our business more profitable and more sustainable going forward. And like I'll use the machine learning in exploration as an example. What is the ultimate objective? Is it to kind of reduce your $100 million exploration budget by 10% because now you're just drilling holes that the computer has told you there's no gold there, or whatever you're looking for? Or is it to kind of completely reinvent kind of your exploration strategy? So you only have to drill, maybe it's only 5% of those holes to achieve the same result. It really just comes down to, I guess it's an oversimplistic answer, but I think we're going to be able to define or know if we're being successful by kind of looking at how we define success ahead of time and see if we're essentially accomplishing that. And is technology and whether it's artificial intelligence, machine learning, or whatever it may be, being innovative, is that helping us kind of to better or kind of to better achieve our goals or not?
Mm-hmm. Nadine, the last word goes to you.
So I think that people have been burnt in mining because they've put a lot of money into a new technology that hasn't worked out. And then they never do it again, and they tell their friends, and then nobody wants to do it. I think that as a board member, somebody comes up to you with a new technology, and you think that's great, and you pass them over, you introduce them to someone in operations, and operations are just like, forget it. I think that we need to look at what is our end goal, as Stephen said. It is to make more money at a cheaper cost, and there are things that are out there to help us. And if we're if there is something that is off the shelf and is working in another industry, like, why aren't we using it? I just don't understand this. It doesn't make any sense to me. We shouldn't be 20 years behind. We should, let's strive to be with all the other industries. We don't have to be ahead of the pack, but within the pack, that's where we need to look to be.
And I think one thing I'll add to that too, I think we just have to accept the fact that R&D is not sort of a linear kind of process. And kind of we can put all this money into these ideas and these innovative ideas, but a lot of them are going to have a 0% IRR. They're not going to return anything for us because they just didn't work. And we can grab off the shelf technologies or apply new technologies, but some of them just aren't going to work. That's just the way of life. But we just have to accept that reality. Otherwise, kind of we'll just become stagnant and keep doing what we're doing. It's not like if we put $10 million into every individual company, if they put X amount into innovation and technology, they're going to get kind of $12 million back. Some are going to get 0 and some are going to get $200 million back. But I think we just need to create tools as a kind of entire industry where we just share that knowledge. So if your company has success with your R&D and mine doesn't, maybe some of that can transfer over, because ultimately if our industry becomes more profitable, that is good for everybody. We all have our plots of land. We're not competing for individual plots of land. So I think if we can take that attitude to it, I think that's where a lot of, someone mentioned Dyson earlier. That's a perfect example. I've heard they've got a 3,000-person R&D team, and I bet half of those people are coming up with ideas that aren't going to turn into profitable applications. That's innovation in general. So, yeah, I agree with you. There will be technologies out there off the shelf we can pull from other industries, and just accept the fact at the same time that some of them just aren't going to work.
We're going to have to leave it there. Thank you so much to all of our panelists today.